Hello, in this video we're going to be talking about Lab 5, molar mass of the gas, the pre-lab questions 6, 7, and 8. So question 6, why did I give you the vapor pressure of water at various temperatures? How will you use this in your calculations? Well, in this lab we were trying to collect a sample of butane gas so that we could figure out its volume and use that to calculate how many moles of gas we collected. So if you look at this picture over here on the right, we collected this sample of butane over water. So we held this lighter underwater and we bubbled it through the water up into this graduated cylinder. It turns out that when we do this, my graduated cylinder is going to be filled with not just butane, but also some of that liquid water is going to evaporate and turn into gaseous water. So this sample right here, which we are hoping to be just butane, is actually going to be a mixture of butane and water. And there's this thing called the law of partial pressures, which is right up here, that tells us that the total pressure inside our system is equal to the sum of the individual pressures of all the gases in our system. So in our system right here in the lab, the gases in our graduated cylinder are both butane and water, so the water that evaporated. So the total pressure in our system is the sum of the pressures of butane gas and of water vapor. In order to find the moles of butane, we need to use the pressure of just butane. So we need to correct for the fact that there's some water vapor in our sample as well. And the way that we do that is by using the vapor pressure of water. So since this equation up here is true, the total pressure equals the sum of the pressure of butane and of your water vapor, you could find the pressure of just your butane by taking your total pressure and subtracting the pressure of water. And how do we find these values? Well, the total pressure is the thing that we measured in class. We looked it up on a barometer, and depending on which day you did the lab, it was either 0.997 or 0.996 atmospheres. And then the pressure of water you find from looking up the vapor pressure of water. That's a temperature-dependent value, so each group is probably going to have a different value there depending on the temperature of your water, whether it was 21, 22, 20 degrees. And this table right here was given on your lab handout, so you can look up the vapor pressure of water. So this is why you're given those, is because you need to find the pressure of butane, you need to subtract the vapor pressure of water from your total pressure. So we'll do a couple problems where we use that. Okay, so let's look at problem number 7. Nitrogen gas is produced in a reaction and collected over water. We've got a volume here, and we've got a temperature, and we've got a pressure reading. So first question is find the partial pressure of nitrogen gas. So just like in our lab, the total pressure is going to be the pressure, the sum of the pressures of your gases. In this case, the gases are nitrogen and water. So anytime you collect a sample over water, you have to take into account this vapor pressure of water. So to find the pressure of just nitrogen, I'm going to take my total pressure and subtract the vapor pressure of water. My total pressure is 0.95 atmospheres. And the vapor pressure of water, I'm going to look up in my table. Notice it's at 25 degrees, so I'm going to go over here, look at my table. 25 degrees, that's 23.8 millimeters mercury. So the pressure of water is 23.8 millimeters mercury. Notice how I can't just subtract 23.8 from 0.95 because these are two different numbers. They're in different units. So I need to convert my millimeters mercury into atmospheres first. And if you look on your equation sheet, this conversion is given to you, that 1 atmosphere is 760 millimeters mercury, so no, you don't have to memorize that. If I plug this in my calculator, I will find that when I convert it, this is 0.0313 atmospheres. So if I subtract those, I've got 0.95 minus 0.0313 is going to be 0.92 atmospheres. Notice how I'm only going to the hundredths place because of my sig fig rules. So this one goes the hundredths, this one goes over to the 10,000ths place, and so you're limited by the number of spots to the right of the decimal. So 0.92 atmospheres is my partial pressure of nitrogen. Now let's use PV-nRT to find moles. Okay, so our equation is PV equals nRT. I'm trying to rearrange this to solve for N, so it's P times V over R times T. My pressure is 0.92 atmospheres. My volume, I gotta make sure that my volume is in liters, so I'm gonna convert 56 milliliters to 0.056, just divided by 1,000. And then my R value is 0.08206 liters atmospheres over Kelvin mole. Notice I got to pay attention to my units here. So atmospheres, liters, and then my temperature needs to be in Kelvin. So right now it's 25 degrees Celsius. I'm going to add 273 to that, and that's 298 Kelvin. Notice how all my units cancel out except for moles. And that's what I'm trying to find, so that's a good sign there. So I'm going to take 0.92 times 0.056 divided by 0.08206 and 298, and that gives me 0.0021 and moles, and that's 2 sig figs. Looks correct there. So that would be my calculation for number 7. Let's do the same thing for problem number 8. So again, I'm collecting a gas over water, same scenario that we did in the lab. Okay, so the total pressure is going to be sum of the pressure of my gas and water. So in order to find the pressure of just my gas, I need to subtract the pressure of water from my total pressure. Okay, so over here, the partial pressure of the gas, let's call it gas, would be my total pressure, 1.04 atmospheres, minus the vapor pressure of water at 22 degrees Celsius. I gotta look that up. That is 19.8. And 19.8 millimeters mercury, I need to convert that into atmospheres. So this one, I'm just going to show it all in one step. Okay, so I got to convert that to atmospheres, 19.8 divided by 760. So this is 1.04 minus 0.0261, because this should have 3 sig figs in it. And 1.04 minus 0.0261 is going to be 1.01 atmospheres. And I'm stopping at the hundredths place because of my, subtraction sig fig rule there. Okay, so now I'm going to find moles. So just like in part B above, I'm going to rearrange PV equals nRT. And my pressure is 1.01 atmospheres. So it's important that you use your partial pressure of your gas and not your total pressure. Okay, so use 1.01, not 1.04. Volume is 152 milliliters. I got to make sure I convert that into liters. My R value, 0.08206 liters, atmospheres, Kelvin, mole. My temperature, I got to make sure I convert that into Kelvin. So 22 plus 273 is going to give me 295 Kelvin. And I plug that in, 1.01 times 0.152 divided by 0.08206 divided by 295, my real-time math here. Okay, and that gives me 0.00634. It looks like I should have 3 sig figs in this answer. Looks like in both cases I'm being limited by my pressure reading here. And the molar mass of the unknown gas, molar mass, is going to be the grams per mole. So if I look back at the problem, it told me that this sample weighed 0.752 grams. In our lab, we're going to find that mass by subtracting the mass of the lighter before and after. And I'm dividing by 0.00634. And so that gives you 0.752 divided by 0.00634, 118. And that was like, yep, I should have 3 sig figs in this answer because both these values have 3 sig figs in them. All right, so those are the last couple of problems of the pre-lab. And let me know if you have any more questions on them.